Welcome once again to this lesson. This is Form 2 Chemistry under the development of the periodic table. We have already looked at the first 20 elements, and when those 20 elements are arranged according to their atomic numbers into periods and groups, we get what we call the periodic table. So let us have a look at the periodic table. This is part of the periodic table where we have group 1 elements in this column. Then we have group 2 in the second column. The third column represents group 3 elements. The fourth represents group 4 elements. The fifth column represents group 5. The sixth represents group 6. The seventh represents group 7. And the eighth column represents group 8 elements. Then of course the rows represent periods. So the first two elements belong to period 1. Then the second row represents period 2 elements. Then the third row represents period 3. And the fourth one represents period 4 element. So the first element, which is hydrogen, takes atomic number 1 or position number 1. Then helium, being the second, comes here such that we have hydrogen, then we have helium, and the electron arrangement of hydrogen is simply 1, that of helium is 2. Number 3, we have lithium with an electron arrangement of 2, 1. Then number 4, we have beryllium with an electron arrangement of 2, 2. Then we have boron. In number 5, we have boron with 2, 3. Number 6, we have carbon with 6 electrons, and therefore the electron arrangement will be 2, 4. We have number 7, which is nitrogen. Nitrogen in atomic number 7 has an electron arrangement of 2, 5. Then number 8, we have oxygen with an electron arrangement of 2, 6. Then number 9, we have fluorine with an electron arrangement of 2, 7. Then we have number 10, which is neon with an electron arrangement of 2, 8. Then we come to number 11, which is sodium with an electron arrangement of 2, 8, 1. We have number 12, which is magnesium with an electron arrangement of 2, 8, 2. Then we have number 13, which is aluminium. Aluminium, being in number 13, it has 13 electrons with an electron arrangement or electron configuration of 2, 8, 3. Number 14 is silicon with 2, 8, 4. We have number 15 is phosphorus with 2, 8, 5. We have number 16, which is sulfur with 2, 8, 6. We have number 17, which is chlorine with 2, 8, 7. Then number 18, which is argon with an electron arrangement of 2, 8, 8. Then we have number 19, which is potassium with an electron arrangement of 2, 8, 8, 1. We have lastly number 20, which is calcium with an electron arrangement of 2, 8, 8, 2. So you can realize from this periodic table that the first group has hydrogen, lithium, sodium, and potassium. In group 2 we have beryllium, magnesium, and calcium. Group 3 we have boron and aluminium, carbon and silicon in group 4. Group 5 we have nitrogen and phosphorus. Group 6 we have oxygen and sulfur. Group 7 we have fluorine and chlorine. And group 8 we have helium, neon, and argon. That is for the first 20 elements. So if you want to identify the group, you look at the number of electrons in the outermost energy level. Since all group 1 elements have 1 electron in the outermost energy level, they are found in group 1. So let us look at the periods and the groups. Groups and periods. Elements in the periodic table can be grouped into periods and groups based on the number of occupied energy levels and also the number of electrons in the outermost energy level. So if you want to identify the group, you see all group 1 elements have 1 electron in the outermost energy level, all group 2 have 2 electrons, all group 3 have 3 electrons, group 4 have 4, group 5 have 5, group 6 have 6 in that particular order. So to identify the group, you look at the number of electrons in the outermost energy level. In this case now we can define a group as the number of electrons. The number of electrons in the outermost energy level. And we know the number of electrons in the outermost energy level, we call them valence electrons. Then of course we have the period. So to identify the period, we always look at the number of occupied energy levels. Since hydrogen and helium have only one occupied energy level, they are in period 1. Those that have 2 occupied energy levels in period 2 in that order. So we can say period is the number, we can define period as the number of occupied energy levels. The number of occupied energy levels will always give us the period. So let us look at a question. Let us look at a question. You can be given a question like this. An element, for example, an element M is in atomic number 19. So in an exam situation, these elements are not given, they are really chemical symbols. So they are given different letters. But we know element M is in atomic number 19, but the element in atomic number 19 is potassium. But we have to address this question in respect to the element M. So A, you can be told, for example, to write the electron configuration. Write the electron configuration of element M. So electron configuration refers to the arrangement of electrons in energy levels, and therefore M being in atomic number 19, the electron arrangement is going to be 2, 8, 8, 1. Then we have B. B With a reason, identify the Roman 1, we have the period, and Roman 2, we have the group of element M. So we have already said that period refers to the number of occupied energy levels, and if you count the number of occupied energy levels, we have 1, 2, 3, 4, and therefore this element is in period 4. Reason we can say it has 4 occupied energy levels. Then if you want to identify the group, you look at the number of electrons in the outermost energy level, and in this case the number of electrons in the outermost energy level, we have 1, and therefore this element is in group 1. Reason it has 1 electron in the outermost energy level. Roman 3, you can be given a question where, for example, you are supposed to draw, or let us call this one C. You are told, for example, to draw the atomic structure of M. So if you are supposed to draw the atomic structure of M has 4 occupied energy levels. The first thing we do is to draw the nucleus or the center of M. Then the first energy level has 2 electrons. So we represent electrons using crosses or dots. I prefer to use crosses for now. Then the second one has 8, so we have 8 electrons in the second energy level. Then we close it. The third one has again 8, so we have, this is 4, 6, these are 8. We close. Then of course the last one has 1 electron. Then we can now close this energy level, and this becomes the atomic structure of element M. Thank you for watching, and welcome to the channel.